Hey, what's going on? It is your boy Jay Baylor here, and I'm back with yet another video. And today we have a relatively simple challenge here. It's this person's first ever Crackme, and someone actually in the Discord channel that I'm in, they asked for help on this particular one. They ended up solving it on their own, which is good for them. But I actually ended up solving it myself, so I thought, well, why not share my results with you all? This binary was written in C++, which makes it a little bit more difficult for me because C++ can be confusing to me sometimes. But the difficulty is on the easier side, so it's not going to be too much trouble, but it is a little bit confusing. Let's just go ahead and jump right into it here. So let's go ahead and do our normal triage, run file on this guy. And we see we have a 64-bit binary. It's pi enabled, dynamically linked, if I can highlight it correctly. And we see that it is not stripped. And no, don't want to do any of that there. So not stripped is always good to see. So let's go ahead and look at the symbols. And because it's C++, there are a lot of symbols in here. And they look pretty messy, as you can see. We see cout, we see cin. Those are probably the only things I can recognize off the top of my head here. And we can see this boring function here. And if you look at this last part on the end, from what I can tell, I think this is like, it's saying it takes in a string, and I think it might take in 2 strings actually. I'm not entirely sure, but I know it takes in at least 1 string. So we see it has a basic string here, and from what I gather, that's how C++ kind of does some things. It's very, very weird. Anyways, we see our main function, which isn't that interesting, but we see it there. And that's about all we can see in terms of the symbols. At least that's all that's interesting there. So let's go ahead and look at the strings. And I'm going to give you a warning here. This author is pretty pretty graphic. Pretty graphic here. So he has some pretty foul language that they put in there. And we see if we get the password wrong, we're going to get cussed out. And yeah, I don't know what to say now, but yeah, the author is pretty graphic there, but you know, it's all right. If we get it right, then we're gonna, you know, get this nice message here, and then we can DDoS the author because they gave us the RP address. And then we see enter the key here, and that's about all that we can see there. Nothing else too interesting. So let's go ahead and look at this in ghidra here. All right, so now we're at the main function here, and we see some things that are pretty, we see things that we've seen before here. So we see there with this going to be a stack cookie, right? Because we see this loading up this chunk of memory here into REX and storing that on the stack. So this is going to be our stack cookie right there. And then, and this is where it gets into some kind of the craziness here. So when we see something like this basic string is a class that can create our strings for us, right? So when we see just like this, that to me what that's saying is it's going to define a string, which is going to be some str, and it's not initializing all. So it's just going to be an empty string here. And so since we don't really know what this is right now, we're just going to say some str. Actually, we could probably say empty str. It might be even more descriptive. So let's go ahead and do that. All right, and then this is where we get into some other C++ craziness. So now we see we have define another string here, and we see first it defines its allocator here, and then it calls basic string, and it has the string that we're gonna initialize the string to, and this is gonna be the buffer that we're gonna store the string into, and then has our allocator. So essentially, what this looks like is, if we were just kind of writing out exactly how it would be, it'd be basic string with I'm just going to call it buffer, and then it's going to have the string that we're going to copy in there, which is going to be this, and we're going to have to get rid of the equal sign. And then we have our allocator. But all of that kind of just boils down to something like this, or if we just say buffer equals to that. All right, so we can go ahead and get rid of that. And we're going to have multiple functions in here, so let's go ahead and do this here. And I'm going to copy And then the other function, I think it was called boring func. And like that. All right. And so that's what that does. And then you see it's going to, after it creates the string, it deallocates this allocator here. And you'll see that pretty often. So when you initialize a string, it creates this allocator. I don't know what this allocator does. I'm still trying to figure that out, but it creates this allocator, and then it's going to essentially call the basic string constructor with these parameters in there, and then destroys the allocator. And you'll see that sometimes, even if we use this, actually, I'm gonna go ahead and rename this to buffer. So even if we were to do something else that requires an allocator on this buffer here, it's going to use a different allocator because this one has been destroyed. So it uses a different one every time. So just something to keep in mind. All right, and so then we see something else that's kind of interesting about C++ is that almost all the things that we kind of do automatically are operators, right? So we see the buffer here gets loaded, and also another string gets loaded in here. So I'm gonna go ahead and copy this, and then it gets called into this plus equals operator, right? And so essentially what that is if we were just again write it out just exactly how it's shown in here, it looks something like this: plus equals buffer, and then that, right? But what we're kind of accustomed to saying something like this, right? I mean, and that's essentially what it's doing. So the plus equals is an operator on buffer, or is an operator that takes in two basic string objects here, right? So we're going to go ahead and just delete this here, and because we can write it just like that for our own sanity. All right, and then we see that similarly we're going to take in this ender key, this string here, and this tmc underscore end here. If we double click on it, we see this actually the cout function name. So if we go back to our function, so again essentially this is cout, oops, and enter key. But of course we're more accustomed to seeing it like this. So it's essentially the same thing, but again, C++ is very strange in how things work. I'm still wrapping my head around it. Anyways, now we see our empty string here, and it gets loaded into this, and the cn gets loaded into this greater than operator here. So essentially that's just going to be, oops, we're going to have, oh my gosh. That is just cn and then empty string. But since we know that's going to be our user input, let's go ahead and rename this to, oops, to user input there. How do I do this? Okay, I guess I'll just press the button. Replace all. I was trying to be cool with all the keyboard stuff. It didn't work out, but it's all right. And then we're going to rename this to user input. All right. Let's see what else happens here. Okay. And this is where we're gonna, that boring function comes into play. So I think this is gonna be, well, obviously this is gonna be another string here, if I'm not mistaken. So this is gonna be some other string. So I'm just gonna call this some stir, and then buffer, and then loads that into this boring function here. So essentially boring function gets loaded into, and then has this some stir that I guess essentially it probably was some stir somewhere like that, maybe, but we didn't see it defined. Something along those lines. And then we have our buffer, right? And so then down here, string some stir, and then our string buffer. I think that's how it goes. All right, so now let's go ahead and jump into here and see what this is doing. And so right now, ghidra is acting kind of silly right now. Instead of actually displaying the register, it's going to display param1 everywhere. But we know this is going to be RDI register because that's just what it is. So, and I can disable this right now. I'm going to disable that. If I go to, tool options, go to listing fields, operands fields. And we can disable this, I think it's called markup register variable references. And while it's helpful sometimes, because it's also, I think it's going to get rid of these as well, but at least for this, in this instance, it's kind of not very helpful. Oh, actually, it kept those. Okay, cool. All right, anyways, ignore that. So now it's a lot more clear, right? So we see that's getting loaded in here. So this is going to be our sum stir, and this is going to be our buffer, which again has, if we go here, it's going to be equal to this concatenated, ooh, big words, concatenated with this. All right, let's see what it's doing here. So again, we have another stack cookie. All right, and then we see that we're loading up these values into these registers here, or into these places in memory here. And we've seen this before where it looks like there's two different stack variables, but this is all just one variable, but ghidra kind of doesn't see it as one. So we're gonna call this, I'll just say CHR for right now. But essentially this loading an X, Y, and this right down here is Z. So if I hover over this, it should show me, yes, see that's the ASCII character Z. So down here, I'm just gonna say char3 is CHR equals to X, Y, Z, like that. And then we see that this local 28 gets set to 0. And then somewhere down here, we see the local 28 being used to as in this comparison here. So I'm just gonna principally rename this to I. So essentially that's gonna be I equals to 0 there. All right, and then let's see. All right, so then, so let's go ahead and take a look here. So that goes into RBX, and then buffer goes into this size variable here. So then we're gonna subtract 1 from that because it's gonna return into REX, and then we do this comparison here. So essentially just going to say it's comparing I and size of buffer minus 1. All right, so I'm just writing that right now because I don't want, I'm just saying that these two are being compared, and I'll fill in the blanks in a second. So when this CMP instruction, what it does is it subtracts RBX and subtracts it from REX, or I guess it subtracts the first operand from the second operand. And the set C instruction, that stands for, I think it's set character, and what that's gonna do is, and I always get confused, if the result of this instruction results in a carry, this gets set to 1. And in this case, it will be get set to 1 because this is gonna, so what happens here is essentially it's gonna be I minus that. That's what the CMP does. And since this is gonna be 0 minus this something else, I think size of buffer is like what, 12 or something. So size of buffer minus 1, which is 11. So essentially it's gonna be 0 minus 11 here, which will be a negative number. So the carry flag will be set. When it comes here, it's gonna say, okay, we're gonna set that, it's gonna set that to 1. And then we would test AL, that's gonna AND these two registers together, and 1 is gonna be 1, obviously. So this jump, if the 0 flag is set, is not gonna be true. So it's gonna come down here and do some other stuff. So I know that was a lot. I hope that wasn't too confusing. All that boils down to is something like this. While I is less than size of the buffer minus 1, it's gonna do this. And so I'm getting this, I'm getting like less than, not less than or equal to or anything like that, because once they are equal to each other, right? It's no longer, they're gonna, once size and I are equal to each other, the result of this is going to be 0, and so this is going to be set C. Is going to say, okay, well, the carry flag wasn't set, and so then it's going to do this test AL, and then they're going to be equal to each other because 0 and 0 is 0, and so that means we're going to exit out of this loop here. So so the only time we continue looping around in this, whatever this thing is doing, so this do stuff here, the only time we continue is as long as I is less than this, because that's the only time that this will ever be, the carry flag will ever be set, right? So that's how I get the less than and not less than or equal to or anything other than or anything else like that. All right, hopefully that makes sense. If it doesn't, you already know, hit me up in the comments and I'll do a better job of explaining it. All right, so Now we get into another one of those things where we see that this operator here, the brackets operator, is being used. So all you can probably guess what this is doing here. It's just going to say buffer sub I. And the result of that actually gets stored in RAX. So this is a function that returns a value and puts it into RAX. And so that is gets turned to R12D, right? So we're just going to say R12D is equal to that. And then we see some craziness here. And all this is going to do here is going to do I, because we see I is getting set into EAX and that pushes into RCX. It's going to be I mod 3. And how do I know it's I mod 3? Well, I had Ghidra help me out with that. I'll be honest. So I mod 3, that gets set into the RAX register. I mod 3. And then we see this thing here. And obviously this is going to be our I mod 3 in here, right? Because we just kind of set that there. But what is this RBP minus hex 1B? Well, let's scroll back up for a second here. And I'm going to go on the CHR and I'm going to Control Shift G on there and I'm going to hit OK. And you see that RBP minus hex 1B is actually this string here. So this XYZ string. So I'm going to rename this to key. And let's go ahead and rename this up here. Maybe key is the wrong word for it. I mean, I guess this is a key. Anyways. So we scroll down back here. So essentially it's going to say, okay, well, it's going to put key into there. So essentially doing key sub RAX, right? So key sub I here. And that's going to be placed into, so EBX is going to have key sub I mod 3 there. Okay. All right. And then again, we see that the buffer is going to get stored into, we begin getting buffer sub I again here, and that gets stored into RAX. So RAX is now equal to buffer sub I. And then R12D, remember that's also equal to buffer sub I. That goes into EDX. And then we see we're going to XOR EDX, so buffer sub I, with EBX, which is key sub I mod 3. So EDX equals to buffer sub I XORed with key sub I mod 3. Okay, and then that gets stored into this our buffer sub I again. So all this boils down to buffer sub I equals to buffer sub I XOR with key sub I mod 3. Oops, key sub I mod 3. And of course you can simplify it to buffer sub I mod or XOR equals to key sub I mod 3. All right. Hopefully that all makes sense, because it confused me for a bit. So if it doesn't make sense, don't feel bad, because it took me a while to wrap my head around this as well. And then finally you see the I++ there. And so that's all that's doing there. It's just going to take our buffer and XOR each character in this buffer with X, Y, and Z. So X, Y, Z. So it'll be X, Y, Z, X, Y, Z, so on and so forth. All right, let's see what it does after that. So now we see that it takes our buffer and our sum string, and it calls this basic string on there. And I think this is just simple copy operation. So I think what this is doing is pretty simple. So we have sum string equals to buffer, and that's all it's doing. So now let's just call this, I guess, buffer mod maybe. I don't know, my variable names are trash. I apologize, but I think that's pretty fair. And we're gonna rename it in here as well. All right, and then I think that's about it. So then it returns, and yes, it makes sure we didn't buffer overflow, and we're not doing that here. So let's go ahead and jump back to the main function. All right. So in the main function, I guess I got to update this too, right? With what did I say? Buffer mod. Oh, Control Alt Enter. There we go. All right. All right, and that's all it's doing there. Okay. And then we see that it's going to take our sum string, which I guess now we could call this buffer mod, and it takes our user input and it calls a equals operator on there. So it's just literally doing buffer mod is user input, right? And so if they're equal to each other, then we're gonna print out our success message here, right? So we're gonna I'll just say success. Else some bad words. No, I will not retype those. And so something interesting here. So when after the equals operator returns, it returns a value, right? And so in C++, anything that's not 0 is true, or anything that's greater than 0 is true. So if our user input and our buffer mod are equal to each other, then it's going to return something greater than 0. And if they're not equal to each other, then it returns 0. So when we get down here and we see that the results of that get stored to EBX, and then we're doing this test here, BL, which is the same thing we saw earlier, that's going to say, okay, are these two equal to each other? If they are, it should, and it's really confusing the way it looks, right? Because you would think that equality, you would want it to be 0, and so it could jump down, but in fact, that's the, that's where the bad, that's the bad stuff there, right? But in this case, it's if these two are, if it's not 0, right? So I guess J and Z, right? Jump not 0, not jump, but like if it's not 0, then we get our well done message here, and then we do our, I guess that's the end line there, and then we destroy the buffer, destroy the user input, and all the other stuff, and then we again do the stack cookie, all that other good stuff. So it's a little bit confusing, but that's just kind of the way it is. But I mean, that's essentially what all this code is doing here, right? So now we've reversed everything and we know what it's doing. So now all we have to do is figure out what this actually translates to. And so I have some code that does that already. And let's see, if I were to, I think I'll call it a dot boring function. Yep. So I actually implement the entire thing, and I don't think this is exactly what the author did, but I think it's pretty similar. I actually did this because I was trying to figure out how all this string stuff worked, the basis string. I was trying to replicate exactly what the author did, but I didn't quite get it exactly how they did it. But this will compile, and it gives us the string. So let's go ahead and compile this. Oh, there we go. And then we're going to say, we're just going to call it test. I don't know. Oh. Dash O, right? Yeah, that's right. And then we do test. And we just type in anything. And there it gives us the answer. Yeah, I was just trying to figure out what it was. But anyway, so that's the string there that we have to give it. I use search BTW. So let's go ahead and test this out. I use search BTW. And there we go. And that's pretty much it. So not a difficult challenge there. We avoided getting cussed out, so that's always a good thing. But as you can see, it was a pretty straightforward binary here, so it wasn't too difficult. And actually, this is my C++ here. This is our pseudo C, which is a little bit more condensed. But anyways, if you like this video, go ahead and hit that like button. I really appreciate that. If you learned something new, also hit that like button. If you have any questions, if there's something that I did not describe, or if there's just something that just didn't make sense to you, do not feel bad. Leave a comment in the comment section below. I will get to it as soon as I can, which is actually pretty quick. If you're not comfortable having your comments on YouTube, you can reach out to me on Twitter, Instagram, Discord. All the information is in the description box below. So feel free to ask any questions you want. If you want to suggest a Crackme that you want me to try and solve, leave that in the comment section below. I can't guarantee I'm going to solve it like the next day, because as you can see, I'm still kind of a beginner status, but it will be on my radar, and I will try to solve it when I get to it. And I will appreciate you for giving me something to try and solve. And of course, when I do solve it, I'll see if I can get in touch with you so I can say, hey, here's my solution. And what else is there? Oh, yeah, that's right. So if you want to see more of this type of content, hit the subscribe button and hit the bell icon so you're notified when the videos go live. I will see you guys in the next one. Peace out.